Welcome to Security Highlights, DornerWorks Cybersecurity Podcast. My name is Nathanael. Today we're going to discuss a few technologies around the Secure Technologies group and what they offer to build cybersecurity into the systems we develop at DornerWorks. Today we have with us Michael Doran, an Embedded Systems Engineer for the Secure Technologies group. Welcome, Michael.
Thank you.
Michael, could you give us a brief overview of the Secure Technologies group and what you guys do?
Yeah, absolutely. So the genesis of the Secure Technologies group, we started off as Separation Technologies, and we initially got this name mainly because we wanted to adhere to really good, strong cybersecurity fundamentals and principles, and one of those principles is security through isolation. Now, this isn't something that we came up with. You know, when we approach our clients or we go approach a project, we like to adhere to a lot of the frameworks that do exist. So, say for example, NIST is a pretty big publisher of what it means to have a secure and fundamentally secure system. And so that's kind of where we got this name, Separation Technologies. However, within the last year, we evolved into something a bit more approachable, a bit, something that made more sense, and we are the Secure Technologies group. So security to us, what that really means is kind of going back to the genesis is, well, we want to do security through isolation. And how do we necessarily do that on embedded systems? Through the advent of hypervisors and through the fact that, we can now leverage swap-C, so size, weight, and power, for these small little embedded systems. We can implement hypervisors that create separate domains in terms of control for your system. So what does a hypervisor do? It allows us to essentially spin up virtualized guests on one actual platform or one embedded system. I can go into an example of that if you want more detail, or
Yeah, sure, that'd
absolutely.
be great.
So in a typical environment, this is definitely technical heavy, so I apologize for all
No, that's
that.
great.
But, in a typical environment, most embedded processors are now come with multi-cores at this point. And so you can imagine, you can spin up a hypervisor, which will have the ability to spin up a guest per core. And so rather than have your entire monolithic kernel or your entire monolithic system all running simultaneously and concurrently, you can now partition them off so that they're isolated from one another. So the biggest example that I'll give, and that makes the most sense, is if you're up in a plane, you don't want your autopilot or your navigation system completely dependent and relying on the infotainment system, right? Because what would happen if the infotainment system crashes and causes an issue with your autopilot or your
That
navigation?
would not be good.
Yeah,
That's
exactly.
definitely happened to me before.
Exactly, and so that's what we try to leverage. Again, kind of going back to those principles or those fundamentally secure items, and it's not necessarily secure from just say like cyber threats and cyber attackers, but just secure from the system itself, and above all. So
you're building redundancy at different levels too.
Exactly. So we have the ability to, add in, real-time monitoring and attestation through the hypervisor of these different guests that are spun up, right? So you can have your hypervisor monitoring, your infotainment system, going back to the flight analogy. You can have it monitoring your network connections. You can, kind of have a thread going on in the background, ensuring that the system is doing what it's intended to do.
That's really cool.
Definitely. So that's sort of the basis, or really the genesis of how our team came to be and how we got our start. And then as we moved more into these projects, we found that, okay, what does it really mean to have a secure system? What other types of tools out there can we use or leverage in order to ensure that we are getting, good isolation? So one of the things that we looked at was ARM is a common architecture for embedded platforms. They have a system known as ARM Trust Zone. And what that really is it's kind of those same isolation techniques, but added in down at the hardware level. And so now what we were talking about before was isolation through software. ARM Trust Zone provides isolation through hardware in addition to software. And so what can you really do with that? The most common use case for ARM Trust Zone now is like your near field communication payment system. So when you go up to like a terminal or a POS and you hold your phone up to it, you can now pay with your credit card. But what's really going on behind the scenes there is a whole series of authentication and encryption that's happening in real time, such that that one transaction cannot be traced back to your credit card. So whenever you hear in the news like so and so or such and such has been hacked, credit card numbers have been leaked, or PII has been divulged to whatever, a lot of what that ARM trust zone can do is mitigate the ability for someone to add in a tracker to a POS and collect all that real-time information.
So you're really building it at lower levels as well as the software level.
Correct. Yep. And that's the cool part about the isolation mechanism, is that if you can truly keep these things partitioned, and say like at an abstract level you want to provide capabilities to certain parts of your system. Think about if you're an architect or you're a mapper and you want to say, hey, you can only get this amount of data flow, you can only get this amount of data flow. It can be unilateral or like unidirectional or bidirectional. And that's really what this isolation is helping us do, is just kind of at a high level saying, you're going to get this type of information, you're going to get this type of information, and you can only interface with these hardware peripherals.
So when a client comes and says, hey, we need this service or whatever, how do you build that security aspect right at the start in your design?
So we pick very strong, I guess, let me back up. So we use very strong tools in order to really embrace that cybersecurity story. If you build a house on sand, that's not a really good foundation. So we like to approach, building software and hardware with the same kind of approach, is that the microkernel that we chose to use and really get behind and advocate for is the SEO4 microkernel. And the reason why is because this microkernel is the first mathematically proven kernel within all of computer science or within the engineering space to date. And what does that really allow us to do is that kind of that capability analogy that I went back to before, is SEO4 really allows you at an abstract level to define the methods and channels of communications in terms of what's really going on at the hardware level, and mathematically prove that, hey, when you compile your code and when you run it on your hardware, we have a mathematical way to prove that this is how the data will flow throughout your system.
So there's really trust on what you're using from the hardware, the software, and all those levels.
Exactly, and then from there it's just implementing best practices, again, as published by NIST. So the National Institute of Science and Technology constantly revises their standards for what it means to have a secure system, whether that be through the authentication of, say, software that will run or update on your phone or your embedded device, to how to establish a root of trust so that you can securely boot your system, and then even mechanisms for performing like real-time attestation. So having a piece of software or a system actually attest that it is indeed the valid software that should be running on that system. And so that's really the approach, is that we're going to take the best tool set, we're going to take the state of the art that exists, and then we're going to implement best practices that are published by these larger, standard publishing organizations, right?
It seems like a common theme we're hearing throughout like different groups at DornerWorks is build that confidentiality into the cybersecurity framework and the integrity of the system from the IoT group, medical group, and it sounds like you guys do the same kind of approach as well.
Absolutely, and so what that has really enabled us to do is, so one big, piece of cybersecurity that we in the Secure Technology group has developed over the last couple of years is the ability to securely boot something. So you talk about integrity, and you talk about having that confidence in executing software that should be executed. And so what we managed to do is on both x86 platforms and ARM platforms is we have an entire secure boot architecture and process that allows us to securely boot SEO4 along with whatever guest operating system you want. And so that can be taken all the way down to the hardware level, where you're performing this root of trust, implementation, say with like a trusted platform module, or you're using certain hardware features, say for example like eFuses or crypto blocks that would be baked into the hardware in order to establish that root of trust. And so once we establish that root of trust, it's then from there, kind of passing or chaining along this same process in order to authenticate and validate any additional software that will execute at any privilege level thereafter. So you can imagine the biggest case that we can probably think of is you have your phone, you want to update the phone software, the OS. From there, you have to have the ability to say like, hey, I know that my phone is going to trust whatever software is going to come from the cloud or come from wherever it is to update the OS, and that all is established with that root of trust, and that's what makes it possible.
So you're talking about these different levels, and that's common in the security world. From your perspective, what is like maybe the most compromised or open to attack, most vulnerable level
Yeah,
of
so
framework?
that's a good question. So kind of going off on a different tangent here. So I just actually got off a 10-day validation exercise with Army Cyber, where I was in with the Army Reserves working through a unit, and a lot of what we were tasked to do was basically assess a network, assess its vulnerabilities, and kind of mitigate from there. All while 3 simultaneous cyber attacks are going on. And so you talk about what are the main vulnerabilities. It really can't be isolated down to one thing. So in this scenario, what we found our vulnerabilities were things such as Microsoft security patches weren't up to date, and so that allowed things such as print nightmare, which is an attack to basically command and control remote servers within a network, right? Well, that print nightmare vulnerability is just, it runs on an embedded system or an electronic system. So there's that aspect to it. Another, I guess, potential threat that we saw was the external facing websites that had cross-scripting vulnerabilities on it as well. And so when you think of an embedded system and you think of what it can do these days, well, an embedded system can be a printer. An embedded system can have a web server on it, right? And so from a network perspective or from a higher level, you're facing the same vulnerabilities that you would otherwise face in a complete enterprise environment. So that's one side of the coin. Now flipping to what is specific to embedded systems and what can be vulnerable, a lot of it can be, so say for example, a heart pacemaker device that was hacked, and the FDA had to go and issue a statement about, hey, like someone can remotely command and control your pacemaker, like that's embedded inside you, right? And
Yeah.
how did that happen? Well, it was just through the fact that there was a lack of encryption and data being transmitted remotely. And so that's one way that an embedded system can essentially be hacked, is that if you don't think of the different attack vectors, if you're publishing or pulling information from a certain source, you have to ensure that that data that's being transmitted is encrypted, can be authenticated. Another, I guess, method of securing an embedded system would be the secure boot process, like we talked about. So being able to authenticate software before it executes, so that way you're not going to get, I guess, attacked through some type of rootkit methodology or some type of framework that allows, some nefarious individual to upload their software to the system. In addition to that, you have the various levels of like ways that you can actually access the hardware that's on the chip. So being able to disable certain hardware peripherals such as JTAG or UART communication, or even leaving a debug port open, that allows an attacker to really survey and get an idea of what the system is doing from, say, a developer standpoint. So those are a couple of different ways. I hope that answers your question.
Definitely. Those are some really good thoughts, and thanks for being involved in this discussion.
Yeah.
You understand how to really build security into the whole system.
Definitely.
Yeah. Any final thoughts as we close up this discussion?
Yeah, I guess at this point I would say that as it's interesting that here at DornerWorks we all have our own definition of what a secure system is, and throughout the different organizations that we have here, whether it be IoT or FPGA, it's really cool to see that we're baking, or we're thinking of security and what it means to have a secure system from the ground level, so that way we really can put our best foot forward and then really try to tie in all these different principles in terms of like what it really takes to build a secure system, how to deploy it, and then how to maintain it.
That's really awesome, and it seems really so valuable as we see all these stories in the news where at one level, something is vulnerable, something's not patched, somebody's forgotten to apply those security practices.
Exactly, and it's what I found too. Just kind of going back to that exercise is that all it took was one weak link, and then the way it was split up is that we had a red cell that was constantly attacking our network, and once they had their in, it didn't take much for them to start moving laterally throughout the network and then sort of elevate privilege and gain information, and that's a lot of what we're doing, even if it's on the embedded system, that can oftentimes be classified information for, say, a government client, right? So, we oftentimes work with certain research facilities, and a lot of this information is controlled. It's not like we can just open it to the public. And so if it's an embedded system that has a web server open, or even if it's just on a network itself, it makes sense to be as prudent about your secure system as you possibly can before you deploy it, right?
Definitely, and it seems like a common theme also is the weakest link tends to be us humans as we implement technology and develop it. So building as much automation and security at every level is really a must.
Definitely, yeah. You can't really plan for the insider threat. That's always the one, I guess, sort of chink in the armor, so to speak, right? But you can add in certain methods. If that insider threat is going to try to execute some malicious code, you can try to attest that code, right? There are different ways to try to mitigate it from that automation standpoint.
Right. Yeah, as I think vulnerabilities continue to evolve, it's almost more of a behavior analytics from any level, insider, external threats, or how data moves egressly or ingressly into the network. So
Right.
it'll be continuing to be more of a challenge as we, I guess, to evolve as a group of people.
Definitely, right. Until the singularity occurs, and
You're right.
the human is just not even a part of the equation anymore, right?
Yeah. Well, thanks so much, Michael. It was really an informative discussion. I really appreciate your time today.
Yeah, you bet.
It is important to choose a partner that understands how to protect your data in all sorts of different systems. Our whole DornerWorks team is working hard every day to build systems that are cyber safe. For now, stay cyber safe.